baby is working and had a good lunch. Yeah, good. Now it's my turn. We do something on technology. Okay, so hopefully we'll try to keep it as much interactive as possible, and that's the best way that you will also make. And I will have a feedback mechanism going on. Okay, so feel free, stop me anytime, anywhere if you have a doubt, concern, or question related to SQL Server. I'll be more than happy. Okay, so feel free, raise it anytime. Quick intro about myself. I'm a technology evangelist with Microsoft. My areas of expertise are around databases, BI, and so on. So those are my core competencies in which I play. I do a lot of work on that. And in the event of doing that, I have an opportunity to share a lot of stuff, and that's what gets into my website. Okay, so the website that you see, Extreme Experts, if you're database programmers, somewhere some search engine would have led you to that particular website. Okay? Accidentally, good, bad. Okay, so during that time, I'm the guy, I'm the face behind that particular website. Okay? And the blogs. Okay, so I do blog about quite a lot of SQL. My travel, because I do a lot of travel, enjoy, and that's also a part of my life in job. So that makes it even more exciting. Okay, dream job coming true, right? Now, what's there for this afternoon session? The first session, the most difficult session as far as speakers are concerned. To keep the interest levels of audience high, yet prove or talk about concepts. Okay, so that's something going to be like a challenge, as I said. But what I try to do is I have a good amount of slides to go through, but there's at least half of my time will be on my management studio, which will be on demos. Okay, so wherein we'll try to re-look at what the features we've talked, we'll look at how it works, and you will see a couple of demos. Okay, so we'll go till they show me a time off. Okay, so the demo session is in the second half, so which means that I just keep on showing you various demos, and as soon as they tell me that it's time off, then we'll call it off. So it will be fundamentally on T-SQL enhancements. Okay, T-SQL enhancements, the transact SQL by itself. It's an interesting guy. Okay, so one second. To give you a little bit of time, couple of minutes at least on this particular slide, which talks about the actual vision, why, of SQL Server 2008. I know I've talked about SQL at various forums, and people have come back and asked, okay, you had SQL 2000, then you took about 6 years to come with SQL 2005, and now what? Suddenly you're coming with SQL 2008. Is that a rational? What are you guys trying to do? Okay. There are so many things behind it. One is when we released SQL 2005, people came back and said, why 6 years? Okay, so at that point in time, David Campbell did make a press announcement saying that, hey, we will release a SQL Server major release every third year. So the predictability cycles have been made. So 2008 is this cycle, and the next release will be to 2010-11. Okay, so automatically that goes without saying. So there is a proper time gap that we are giving. At the same time, we are also giving customers, you as customers, time to go ahead and be ready for the next wave that is coming your way. When SQL Server 2008 was started, product team advisors said, okay, what are the different pillars that I need to concentrate on? And so the fundamental pillars that people went with were the 4 major buckets. Okay? Now people will be thinking, okay, right, where is the security pillar? You guys talked a lot about security. Yes, we said that security is not a pillar, it's a horizontal. It has to be on each and everything that we do. So we don't want to call it out separately, but we want to just embed it as part of our product, immaterial value or something. Okay, so that is across the board. So we went about doing enterprise guys, a lot of work, the big daddies, if you want to call it, Barnes & Noble 350 outlets, distributed system, 170 terabyte on Malaysian government sitting on. What do we do for these guys? These guys, like I don't know how many of you do know, are living on the Airport Road, where the shop value you would have seen. Okay, there's an ad for shop value. Shop value is what is a big SQL customer for us. 1,600 SQL servers doing replication. Can you beat it? Guess the number of DBAs? Any guesses? 1,600 servers. dispersed across 2 locations. How many dBs? 50? Is that good enough? Do you think? Don't we need more? Less than 15, 1.5. Okay? That's what it is. Okay? How can I give more with less, yet enable you or empower you to do your complete operations? Okay, that's important to us. That's our enterprise customers. Okay, so a lot of features that you will see, you will get into that. Beyond relational, there are. Okay, so life does not start and stop with data being on rows and columns. It is as files, it's as Word documents, it's as Excel sheets, it's in so many formats. Okay, XML, to name it, we have it. Okay, and these are also incarnations of files or data. And what do I give you as a developer in that space? Okay, so that's where beyond relational goes. Dynamic development is all about link and other things. I think so. You guys had a bit of earlier in the morning where Pandu was alluding. Link comes down very much. I think so. The 4th session I think is on link and dynamic development a bit. So Vijay will be back. We'll talk about that. So a lot of work has gone into that. BI is the last one. Okay, so BI, we have done a lot of work on BI, and that's what will reflect into that last one. So that's the complete pillars. Okay, so I just want to talk on that vision. So as far as the agenda, just SQL enhancement. Okay, we'll talk about the various enhancements. Okay, I'll talk about the data types. We'll talk about merge. We'll talk about PVP. We'll talk about compression. Some people like compression, and if as and when time permits, I think we'll surely take up other features also. How many of you have heard about SQL Server 2008? Heard about it? Worked on? Just one hand. What did you hear? What are the different things that you heard on SQL 2008? I know it's the afternoon session, I respect. Okay? It doesn't need to be a monologue, it could be a dialogue. Okay? What do you hear? Doesn't matter if it's good, bad idea, I'm ready to take it.
It's like you can show files in file systems data.
Okay, files in file system. That's the new feature. It's called file stream. Okay, it's very good. Yeah, resource governor. Okay, how many have heard about resource governor? Just one. Okay, resource governor is a wonderful, wonderful feature. I think so. That goes into more of the administration. That's why I didn't put it here. That is also the case with file streams. A lot of administration and type of work. So that's why I haven't had them here. But yeah, those are real new features. But let's see how long this goes, and based on that, if you have time, we'll do even resource governor. That's even more interesting. Anything else you guys have heard about? There's a lot of hands going on. Here you heard about SQL development. Compression merge, yes, very much yes. Thanks a lot. Varchar Max was already there in SQL 2005.
Date
time, data types separated, new data types. Yeah? Geographical data types. Okay, I haven't seen people talk about that a lot. Okay, geometric and geographic data types. Okay, both the data types are supported. Okay, full-fledged support. So there's a lot of things. Okay, so the idea is that in this 1 hour capsule, surely I will not be able to do justice to talk about each and everything, but at least it will be representative, if not exhaustive. Okay, so I'll also give you a laundry list. Okay, the laundry list looks really big and yet incomplete. Okay, because it keeps on getting added. Now let's do a small quiz for people who have already worked on SQL Server. How many have worked on SQL Server? Some capacity, most of you. Good. Tell me, what do you find new here? First statement. What is so new about it? Yeah. Initialization while declaration. Second. Double draw. Okay. I never had to even believe or remember how many methods or classes that I had. Not even required. Comes inside. Okay, so quite a lot of stuff. Okay, that is not the selling features. These are delights. It makes you feel happy. Heart pumps one more beat extra. Good. Okay, so that's about it. The real features come next. Okay, so let me start with date, time, data type. Okay, that is date is separate, time is a separate component. Date, time, data type in their own incarnation are 8 bytes in nature, and they have their own limitation. When people vendors say that, hey, I want only the date, I want only the time, and more often than not, 9 out of 10 times, I've seen people go to one page which is there on books online, which will be either on cast and convert. Okay, and why they go there, I'll tell you. Because they have no clue how to store which format. Okay, is it 101, is it 111, or is it 121? No clue. Okay, so more often than not, you go there. Now we give you a separate data type. Okay, complete, full-fledged data type separated as date and time. Apart from that, we give you 2 other extensions. One is called date time offset, which means that all of us know that here GMP plus 5.5 hours. So that plus 5.5 hours type of an approach. You have a marker of an UTC time, then you have a marker which says you are plus so much or minus so much, and so on. And then we give you one extension which is called date time 2 variations. Okay? Date time 2 is similar to date time data type, except that it has got a higher precision. Now, can somebody tell me what was the precision level in SQL Server 2000 or 2005 for date time? It's just starting, it's not. Yeah? How much of a millisecond? Yeah? 999? What is the precision level? Precision is he said millisecond. He said 10th of a millisecond, 100th of a millisecond, what? Yeah? We almost had it. 3,000th of a millisecond. Okay, so that's where, so 0.003 would be there, the precision level. Okay, so we go there, we beat that numbers also. So we go up to 100th of a nanosecond, which is very much in line with the .NET data types that we have done. Okay, so that was a fundamental need. Okay, why did people want it? Okay, fundamentally is to go back and say that, hey, you have a .NET data type which is giving you 100th of a millisecond. How the storage engine or the storage system is only able to store up to 3,000th of a millisecond. It is quite limiting sometimes if you want that level of precision. Okay, so obviously date time 2 data type gets that extra edge. So you go on writing date time 2 of 1, date time 2 of 2, date time 2 of 3, date time 2 of 4, keeps on going, that increases your precision level. Okay, date time 2 of 1 means this 10th of a second, of 2 means 100th of a second, of 3 means 100th of a 1000th of a second, it keeps on going. Okay, so that's the next part. Completely ANSI compliant. Okay, you were sitting on Jani's session. As much as possible, most of the features are very much compliant to the SQL standards. Okay, so we have gone very aggressive on some of them. Completely compliant on 1999 for most of our infrastructures. SQL 2003 compliant and 2006 strict ANSI compliant. Okay, so we're completely very much compliant to our ANSI in the standards. Fundamentally, it makes a lot of, so if people ask why are you getting into the standards mode, because fundamentally it's for interoperability. We respect that people have, or inside your organizations, have databases which are on heterogeneous environment, and obviously the best way you can interact or interoperate is to have a standards base. That's the reason why we are trying to stick as much as standards oriented as possible. Okay? Any questions?
So before we had a format date type. So now you have split that given that one.
No, that's separate. That's it.
Format type.
Okay. Format type. So what we did as part of this is that we did a lot of extensions to the date part. If you have seen the date part gives you specific components of your date and time. So we have gone ahead and extensively extended that. Okay, so earlier, so you had one page to go and read, but now it's sliced far more better. You'll have 3 pages to go and read. Okay, because there are so many options available. Like date part of month you want, or date part of milliseconds you want, date part of nanosecond. We just give you that extension. So like for example, at some point in time it can mean that a time plus 5.5 hours and time plus 10 hours may be the same time. Because the region or the origin, one says is Australia, another says India. So we give a complete flexibility on top of it. You can use it in group by, you can use it in all the places that you like. Okay, so that's what, it's a full-fledged data type. It's not a half-baked data. We're giving you as a full-fledged data. Okay? Let's get going. Next feature. Okay, so we go jump, feature, jump, feature, jump. Okay, so next feature is merge. Merge is an interesting candidate. How many of you have heard about merge? Merge, just one hand goes up. Okay, merge in their own incarnation can be thought of as absurd. Okay, so I've seen people using this word absurd. Absurd, okay, it looks like an absurd word, but it's a combination of both insert and update. Okay, we went ahead and implemented the SQL 2006 standards to say that we will support insert, update, and delete in one stream. Okay, no, they don't make any sense. I understand. So now that's where I will demystify. What is that? Okay, so you have ETL type of workloads happening in your system. Like one of the things that you might want to do is that you have a source. So somebody is giving you a data set or a row set. You have a row, you have a table of data. Based on certain conditions, you might want to insert, you want to update, and you want to delete. And a normal convention is to write a procedure. A stored procedure, loop through the source table. If match, do something. If not match, do the next thing, and so on. That is what happens. The source table is there. The target table is there. If they are matching, you update it. If they are completely new, insert it. If they are not matching over here, then go ahead and delete it. Okay? So 3 different operations. This is what you wrote in the procedural code. Right? Now I'm giving you one statement which will do all these things. One statement which can do that. So now what this enables you as a developer, okay, it's a lot of code gets compressed. Second thing, it's an in-memory single logical operation. Vis-a-vis earlier, it was a looping mechanism. So the amount of overhead and the CPU cycles that you were using was very, very high. And this is going as one shot. Boom. Just insert update and delete. All 3 go in one shot. Okay? Does this sound any interesting to you guys? Like for example, you have the source, you have the target. Okay? What is happening is that when it is matching and certain data is changing, then you might go ahead and say delete. So there are no rows, based on some data condition, then you delete it. It is matching, but the data is not becoming 0, so I'm doing an update operation. There is no matches, I'm doing an insert operation. Are there any questions on it?
Basically, you are claiming that you are replacing this command with cursors.
It can be thought of. So that is one of the main implications.
Still, we have to use cursors.
You don't have to use cursors in your code. How many of you still use cursors? Go on.
Only for merge?
No, I'm asking you in general. How many of you using cursors? Like there's quite a few hands that are going. You can do away with cursors and still write a looping query. There are ways of writing transact SQL loops. Okay, because you already have the result set. The cursors have that. Okay, cursors were an incarnation of SQL 7. Okay, that's when you didn't have when you started the procedural language paradigm. That's when we introduced cursors. But after that, there are certain things about cursors which are not that good about. Okay, one is from a resource point of view. Second, in general, how many of you write declare cursor name and then you go about writing the select statement? Is that the way that you write? Yes? Yes? Okay, right. Fine. So that's the mistake. Okay, that's the catch. The catch is, in essence, whenever you write such a cursor, you are writing a very sensitive cursor. We call it a sensitive cursor. Sensitive cursors are nothing but can also get you frantic loops. Second, cursors in their own inherent nature will lock the records. That's the next thing. Okay, so these are the aspects of cursors which are really best because it is highly resource consuming, both from its CPU cycles as well as from memory requirement. And forget not the IO cycle that is using for the actual reads. Okay, so you can do away with that, and the ways in which you can do, you can go to my website. I have an article on T-SQL looping. Okay, I have given 3 different methods using either temp table or table variables, where you can go about doing it. Okay, so they're already proven. It's not big rocket science. It's easy to go ahead and change them. Because when you move to the table variable mode, it's a snapshot of the data. So your fundamental main table is never touched after you have taken the snapshot. Okay, and that's very important. So the best part is, once you have taken the snapshot, you have this temp or you have a working table, and you are working on top of this. And what you can do is that after you finish, you now have a complete, like something like a table set, which you might want to go ahead and merge it with the main table. You might use merge first. Got it? Okay, so
when you have a large volume of data, what will be the performance impact when you are using merge?
this is 10 or at least 1,000 times faster than your normal cursor looping. Okay, that will be the at least the impact that from impact point of view. The reasons why, because you have only one data structure being created here. Whereas in your normal cursor codes or any other code that you'll have more than one data structure that holds the data. That is your current data and your updated data. And at any point in time you're doing that, what you're actually doing is that you're trying to create another temporary location. So, like for example, in case of strings or other places, right? Completely you're creating another data structure. You have to create. So you will have duplication of memory issues. Okay, so this will be surely in the order of hundreds and thousands faster, for sure. Okay, so that's why you should be using and you should be thinking on this. I was expecting even more interest in places. Okay, this is our developer summary. You guys are developer. You guys are hardcore devs. More often than not, when you write a procedural code, every alternate line is an attach error. What happens to that? After an insert statement, there's an attach row count. What happens to that? For any source table, you write, if you have a trigger, what happens to that? You want the answers? Yes. That's the important thing that I want to capture over here. Okay. So in SQL 2005, we introduced a concept which is called PML with output. How many have seen? Insert statements can have output clause. Output clause will give you the inserted and deleted pseudo columns available in the DML statement insert. Right? We give that extension for merge also. So the merge, the bottom you're seeing output action. Okay, dollar action will tell you update, delete, insert. 3 keywords in this video. Okay, and then you have the pseudo column. So inserted.delta and deleted.delta will also be available. So you can take that and put it into another table and then work it off. Your triggers on the other case. Okay, so triggers, what happens to the triggers? Your add row count will give you the total row count. So 2 insert, 3 deletes, maybe 1 update, 6. Add row count is 6. It will not come and tell you that okay, it is how many were insert, how many were deleted. It will not tell you anything. But add row count will tell you that. On the contrary, your insert or your update or your delete triggers will get a batch now. Okay, earlier the assumption is that as you loop and do it, you are going to get only 1 row. So you might take it and then you might log it once. You might use a single insert statement. Now you will get a batch. So you will have to change your code to accept a batch. That's the deal over here. Okay, so that's when it makes it as much as these codes. So what is happening? You're compacting. Okay, so all your operations are getting compacted. You're doing it as bulk ETS inside the system. Okay, so that's why the performance automatically will gain. Okay. Yeah. Output statement will give you, if it is 6 rows, it will give you 6, all 6.
Suppose processor depends on one statement. It's like first statement is success. It should insert 1000 records and it should insert 1000 records and proceed to next statement. In that case, how it will?
So that's the deal. Next thing. This is an all or nothing. This is a Boolean file. In your code, if you wrote a procedural code, the advantage was you could go ahead, if you had invalid records, you could go ahead and say that, okay, I will not do this operation. We'll skip that. That's the advantage you got with respect to flexibility. but it wasn't the most performant code you ever wrote. So that's one other paradigm that will be different. Okay, so if you want things like the cascading, and then I have the source, I put it, and then I got to get all the identity values and then run with my child, all that, then you will have to build that logic. Okay, so like for example, even in a batch, okay, let's assume that if you have parent and then you have children that have to be done. When you insert a parent as a bulk, the output $action with inserted that ID will be a batch. That will give you all the IDs that it has generated. Then you go about using these IDs and insert your child. Okay, so obviously the code would become compact, but the trade-off between performance versus the flexibility is the trade-off that you're getting. Okay. I'm not telling that it's a replace of all the looping queries. Obviously, for certain batch queries, this works well. Now I'm talking about batch. How many of you ever wished, at least to some extent, that hope I had a way to pass a table of data or an array of data? Have you guys ever wished for it? Yes? Yeah? So the best part is table valued parameters, we don't have it. Okay? At least we don't have it in the state that we are good. We have an extension to that. Okay? I want to introduce two new concepts over here. I want to introduce table types. Okay, so you have user-defined types. All of you would have worked on user-defined types. Fundamentally, in any application where you want to standardize on certain things, like for example, the name field has to be always varchar of 50. Okay, so that's the requirement. Doesn't matter if it's a personal name or it's a company name. I'm not worried about it. But I want to use that varchar of 50, and I don't want anybody to override. So I'll create my own type. Similar to that, we are introducing something called as a table type. Till 2005, we never had a way in which we could. The idea is to persist the metadata. Is to lock the metadata and keep it. Okay, so that's the whole reason why we introduced this. So on a table type, it is like create type, and then you. How many of you created table variables? Table variables, declare, add table, open parenthesis, keep on writing it, right? So that is. So the point of a table variable starts and ends in your begin and end block. So it is scoped over there, right? So it is outside the scope, it is not visible. Now let's get to the next guy, higher on the hierarchy, temp table. Temp table, decent enough scope of the stored procedure. Starts there, ends its life there. Fair enough. What else do I have? I have global temperature. The problem global temperature tables is across the connections. It is as good as persistent table. It is nowhere different from an actual persistent table. The only difference is that in a persistent table it will be available after a restart of SQL Server, but here it is not available on restart. I don't have a mechanism where I have this table available for the connection. Getting it? The whole connection. So for that, you would go ahead and create a table type. So the table type defines and locks the metadata. Hence, it is available during the whole connection period. Because I can always go to the IO and bring that definition. I always have it somewhere persistent. I bring only the definition. This is only definition. A table type will not have any data. Okay? So you create only a type definition. After you create a type definition, you can go about and passing this type with data. So how do you pass types in stored procedures? You just create proc, you give the parameter, add parameter name, and then you pass a type, data type, right? Integer, varchar, something. Similar to that, you will pass table type. Very simple concept. Okay. So this table type can now carry data with it. So the front end sees it as array, we see it as table. The radio.net will send it as like an array. We will use it like a table. Okay, and then you go about doing some operations on top of it. Okay, the only should I call it as limitation or should I call it as the restrictions is that in the current incarnation, the table type that you're passing, that is the parent passes it to a child procedure. The child procedure, it is only read only. The parent can do anything he likes. He created it, he can insert, he can update, he can delete, he can do whatever he likes. But when he's passing it, he's going to have it as read-only copy for the child. That's the only restriction that we're giving as of now. Okay, let me just quickly get into two other concepts, and then we are done with PPT. Okay. Next is compression. Okay, compression's various incarnations. SQL Server 2005 SP2 introduced a compression technique for bad decimal. So for bad decimal, we had a special type for compression. Inside SQL Server 2008, we are giving a complete end-to-end compression. Your row, your page, and your backup compression is also available. Okay. Now you come back and then you will say that, okay, right, is it like the standard way? Anyway, bar charts were like that. You only store how much you want. So it's already as in like in compressed format. So in what way is it different? Okay, you are going to compress for data types even like integer or standard fixed length data types. The specifics of compression surely I can't talk over here for at length because it's such a short duration hand. But the idea over here is that we store only how much of space that particular data type is actually consuming. Like for example, let me give you a quick point and case example. I have an integer data type, how much of space will it occupy? 4 bytes. Very simple. I have a value of 1. Value of 1. How much do you need on the disk? 1 byte. And what is the extra 3 bytes? Okay, so when you say it's compressed or it's in row compressed or page compressed, automatically the 3 bytes, we will not store it as 4 bytes, we will store it as 1 byte and 4 bits. Okay, so that's the space savings that you're going to get. Okay, so huge amount of space savings that come out. There are various things that are part of this. Okay, there is something called as page compression, there is a column compression, and then you have row compression. Okay, so that's where. So that's about it. Okay, so no more PPT. So we're done with the PPT. So let's get into the demo rep. Okay, so I'll try to show you as much of code as I can. The next 15 to 20 minutes we'll have a Q&A at the last. I'll try to allocate at least 5 minutes so that you can ask me any questions. If there are no questions, then we'll go on with more demos. Okay, so that's the way it goes. Okay. Let me come back here. I hope everyone is familiar with this interface. Management Studio, nothing different about it. Okay. In fact, it is running SQL Server 2008. The look and feel, everything is the same. There's no difference that you will see with respect to 2008 and 2005. But there are certain things about this management studio that make it interesting. Okay. So what I'm doing over here, just to show you first is date and time. So let's do date and time data type. We have talked about it. I went these guys aside so that you get a little more realistic. Okay, so that's next is let's create. So as I said, date time 2 of 0, 1, 2, 3, and nothing but precision levels. What level of precision that you want? Just creating that. And just inserting certain dates, just to show you what are the limits of the dates that are there. You can see the differences that come out. Okay. One is with all 9999 goes up to that, 100th of a millisecond, 10th of a millisecond, so on. So obviously the precision level alone is changing over here. Okay, so that's the difference that you see. Next is with the offset. Okay, so it is all you have to say is that it's an offset time. So you can see here offset time. That's what I want to give. Okay, so let me just insert some values and then show you what comes out. That's simple. So you go about writing just saying that it's plus 5.5 hours, so on and so forth. That's about it. Okay, so obviously the offset is massive. Okay, so you can go ahead. The date part gives you complete flexibility on using this and comparing two dates. Okay, and with the region encoded, you can automatically save this. When I was talking about compression, nobody raised a question on performance. You guys, do you feel that it will be the most performant code? Yes? No? Because we are doing something extra on top of it. Yes? Yes. So, what I'll show you one incarnation of a compression which is on backup. Okay, so backup compression is something that I'll try to do. Okay, here, in this particular example, let me just pull out my C drive. So I have it here. Okay, so that's there. Okay, my C drive does not have any backups as of now. Okay, so there is no ADW backup. What I'm trying to do is, I'm not doing anything specific over here. I'm just creating a backup. The reason why I'm using T-SQL is because there is a log that comes out. So automatically it's easier to catch that. To see how much of time it's taking. Okay. So just trying to say I got about 6.3 seconds. Okay, this is a AdventureWorks, which is our sample database. Pretty much large. It's about 150 MB in its own size. So that was good. So let me go ahead and then do a compressed backup. All I'm doing is I'm doing only two changes. Changing the backup file name and adding compression to it. So it is supposed to be doing something is wrong. You must be doing something behind the scenes. Something is really wrong. There's nothing wrong about it. The only thing that changes is over here. You can see at one side, I'm writing 73 MB, on the other side, I'm writing 5 times of less IO. Okay? So the deal of any compression technique is very simple. The cost incurred in decompression is more than the cost or the benefits I get by reading, then compression is bad. Because the time to read it and then decompress it is becoming so large. So the benefit I got by reading lesser IO has been overshadowed by the processing cost that I use. Okay, so the IO benefit that you are getting is actually giving me back the time. It wrote only 15 on one side, about 12 MB, on the other side it wrote only 70 MB. So 5 times of IO benefit I got, but my in-process stuff that I was doing was negated because of the total time that I have. So that's where compression becomes useful. Okay.
So what about restoring? So you restore.
Let's restore. Okay. No changes. Change is the same. Okay. So here I'm doing the normal backup. Here I'm doing the uncompressed. So you see on both the sides, the code is the same. There is no extra line which comes. There won't be anything that I wrote extra, saying that it's a compressed backup or something. Okay, I have not written any other extra code. Let's be very sure. So I'm going to restore it. Now this is a non-compressed backup. Okay, that is not compressed. Okay, so that is what happening. Let's restore it. Should take now about 7 seconds. Okay, so here it goes. 9114 pages, 5.63 seconds. Okay? And this is the compressed backup. 9114 pages is what we read. Yeah. See, end of the day, what is happening? Who's giving us the benefit? The IO is giving us the benefit. Both have to get restored as 150 MB. So the writing part, both of us are equal. You also have to write 150, I also have to write 150. But to get that 150 MB of data, I read 74 MB on one side, whereas the other guy says I read only 15 MB on the other side. That's where it is. Okay, so that's where I really get the benefit with respect to saying that, okay, right, where the IO gives me back the time for the benefits that it's needed. So doubts clear? Okay. So as I said, the mantra is very simple. Okay, the point wherein the IO benefit gets overshadowed by the decompression activity, compression becomes bad. But if the IO benefit is far more superior, to the decompression activity, then your compression becomes good. And in essence, we have seen this at large customers. Let's be very clear. I've seen at some of the large customers where the CPU never touches even double digits. Okay? They have it at that layer, 7 or 8%. I can use on that. But on the contrary, the hard disk is something that you cannot go and optimize anything. You have a single disk which is doing both read and write. How can you go and optimize it? The max you can do is you put RAID, you put SANS, that's it. What else can you optimize? So if I can reduce the amount of time I wait for an IO cycle, then I'm getting this result. Okay, so with that, compression is done. Let's okay, so I just want to show you some of the benefits. Okay, so let me just. So the idea over here is to create a table. Okay, it's not representative. Let's be very clear. Okay, I'm just showing you for data compression. Just showing you what all you can, how much of savings that you can get. I'm just storing 2 columns over here. C1, C2, and C3 is char of 8000. Char is null padded. Remember that, right? So it's not bar chart. Okay, so char is null padded. So I have data and then I have padding behind it. Okay, so what I'm going to do is I'm going to insert various values. So remember the time when I said 4 bytes for an integer, if I store only 1, it's going to store only 1 byte and 4 bits. So automatically the space savings are going to come out like that. So what I'm going to do is I'm just going to insert some 6,000 rows. Obviously just execute it. So this space use you would have used. Okay, fundamentally tries to tell you, okay, right, I have 6,000 rows. I have about 48 MB of data. And now, if I do different levels of compression, so I have 2 levels of compression. I have a row compression, I have a page compression. Okay, so that's what I'm trying to see. So if I do row compression, how much of compression savings am I going to get? If I do page compression, this is like a what if analysis. Okay, so here it is. Let me just run that. Okay, what's the difference between a row compression and a page compression? That's something I have to quickly tell you. Row compression is inline data. Okay, like for example, within a page, if I have multiple rows having the same data, then I will store that single data and have a pointer from both the rows within that single page, which means that I have reduced the redundant data within that single page. Now, any page can never be filled for the complete 8000 or 80992 to be more precise. You will always have something which is free. There's something that is free. In this particular case, data-wise, whatever data I inserted some AAA, which is replicated some 60 times. That's the data. But the rest of them is a null padding. That's not a data. So page compression, on the contrary, will remove the extra free space within a page and all those null pages also, all the null data also. Okay, so that's why you will see that row compression is normal row compression. Page compression is row compression plus this extra. So automatically you are going to see here the number of pages that I am going to use. Okay, so current size is here. You can see how much of size it is reducing. One side it is telling that I just need 488K if I do just page compression. That is here. And if I do a row compression, if I do a page compression, I just need 104 bits. Huge amount of savings that you will see. Okay. Any questions?
What happens when you query the data?
Nothing. It gets decompressed. It gets decompressed. It will not get lost.
No. Is it faster or is it the same? In terms of querying speed?
In terms of querying speed. Okay, so again, it comes back to the same point, IO or CPU. Okay, like for example, if you did select star from this T1_big, if it was not compressed, then you are querying or waiting for 48 MB of data from the IO subsystem. If you did a row compression, then you are reading only 488K from the IO subsystem. So your read has become faster. Now that gets loaded up into an 48 MB. in-memory. So automatically that's where it is. Okay.
So what is column compression?
Okay, I'll tell you on that. So similar values. That's a classic example of a column compression. Same values in the row as in the row compression. Okay. This is again, if you are thinking, that this is still not clear because a table becomes compressed. No, there are different levels you can tell. You can tell that I want a table to be compressed. I want a partition in a table to be compressed. I want only this index to be compressed. I can give all options. So you have granularity over there also. Okay, so we give a complete end-to-end support on top of it.
If you do page compression, it will do all column compression, row compression.
Nice, yes. So page is the ultimate. It will do everything. Okay. So the best way is, okay, I have seen this. Okay, which are the scenarios where we will use this? Anywhere you are having archiving data makes a lot of sense. How can I get best returns of my investments on the hardware that I have invested? Especially for archiving. And if you are questioning, okay, why is archiving happening? Each of us use, at least in some incarnation, have access to a system which does archiving. How many of you go to banking sites? Online banking? All of us do this. At least I have seen sites not giving more than 6 months of data, 3 months or 6 months of data. Where is the rest of the data? It's there somewhere. It's an archive. But the amount of people, if you tell that I have 1 million people who are my customers, then the percentage of people asking for an 2 year or 3 year data is very minuscule. It will be less than 1% actually, if you look at it. So that time, if I go to an archive system, I spend a little bit of extra CPU cycle to read it and decompress it and give it, I'm fine. But for my current running application, which is in a banking scenario, for example, if I'm talking about it, I can go back and say that if you're having 3 months of data that you're showing, at any point in time when the user comes in, first he sees his current month. So the current month or the current partition need not be compressed. It can be completely uncompressed. The previous month and the subsequent month before that can be either page compressed or row compressed. So by doing that, I get the benefit of both compression. At the same time, the OLTP system is going to write only on the current month. The banking system does not allow you to go and alter anything which was in the previous months. So I know that I have blocked it on one side. Getting it? So that's what is important in going and correctly designing your partitions, how your data gets partitions, and how you're going to add compression on top. Okay?
Excuse me.
Okay.
But one small question.
Yep.
See, if the compression is having such an effect on the data and everything, then why SQL 2008 is not coming up with this by default? Like whenever we are having a installation, why all the data are not getting compressed?
Okay, so the way in which we go ahead with all our new features is very simple. It is turned off by default. All our features are turned off by default. You've got to go and turn it on. The reasons are very simple. It's to give you a consistent feel of how you were before. We have given you the option, go ahead and start using it. Okay. Second, the data is yours. We have no clue on how you are actually partitioning it or how you should be. By default is started. Now, if you go ahead and install it in Windows Server 2003 and 2008, it will install only the binaries. It's not started. Because that is by default. Secure by default is the standard in this case. Okay, so that's one of the major reasons why I want. Okay, I'll just show you this. Okay, so this is a demo of both merge and TBP. We talked about this merge, the batching operation, and TBP. We talked how do you pass table across. So my intention over here is to pass a table somewhere to a stored procedure, and the stored procedure will do one bulk insert. Okay, that's this very simple scenario. And for the scenario, I'm just using a stock ticker. So I have a stocks table. The stocks table has got data about which are the companies and what is their value currently. So as on date, this is what the company and the value is. And I have another date or the daily timer ticker, okay, daily trade, which will tell us, okay, it went up by 5, it went down by 10, so on and so forth. And then I'll reconcile it after every day. And during the process of reconciliation, if I see that some data is is missing, I go ahead and insert it. If I see if there's a matching record, I go ahead and update it. And if there is a matching record and the value or trading value becomes 0, I will become value deleted. Okay, very simple scenario that I'm going to use just for demonstrate. Okay, so the stocks application. What I'm going to do is I'm creating my stocks table. It's got 3 rows over here. Okay, so very simple table, 3 rows. It's got MSFT, it's got 200, Reliance has got 50, Wipro has got 500. This is the current number of stocks that I have and the listing I have. Now I'm going to add the daily ticker. Okay, so for that, the daily trades table has got a whole bunch of values that I'm adding. Okay, so I'm adding a whole bunch of values. So in this particular case, I'm saying MSFT is plus 55 and minus 25. Okay, so cumulatively MSFT has gone up by 30. Okay, Reliance is RIL is minus 50 over here. There's no other trading that happened. Okay, so there you go. Okay, so here you can see the row constructor I used. Okay, one shot, all the rows are gone, all the 7 rows are gone in one shot. Next is to create a type. Talk about this. Create a table type. So it is similar to creating your table variable. There's almost no difference about it, but it is persistent. So it is available across connections. After you create it, to use it is very simple. It's like a normal data type, but this will return you a table, which is nothing but it's a table variable now. Again, okay, so nothing much different about it. So what I want to do is this. I want to reconcile it for the day. So reconciling it for the day is to group it by the values, so that I get the final value. So this is how it is. So this table has to merge with the parent table. So wherever there are records which are found, go ahead and update it. Wherever there are records which are not found, like for example GM and Cisco were not there in my initial list, so you have to insert these rows. Reliance on the contrary would have been plus 50 there and minus 50 here, so it becomes 0. So if the quantity becomes 0, delete it. Okay, so I'm going to do all the 3 operations in one go. And we were talking about merge statement, and I was talking about passing these parameters. What I'm going to do is I'm going to create a stored procedure. Okay. Now before I create a stored procedure, I told that there was one restriction that we had. What was it? Read only. So that's here. Okay. So when you pass it, we say it's read only. That's it. As soon as you do this, I say merge the main table with what I'm sending you. Matched on the stock name. If the quantity becomes 0, delete it from the main table. If the quantity doesn't become 0, but there's still a matching going on, go ahead and update on the quantities. You can see the row constructor I've used, the operator overloading I've used here, just for simplicity sake. And if there are no values found in the parent table, go ahead and insert it. So all 3 happening in one go. So the stored procedure is created. Now let's go ahead and pass the table. So I do the same operation I did on the top, just for viewing it and just showing it. And you can see that I'm passing the table variable here. That's it. One go, done. Yes, so you can see that I started with 200, 50, 500. I reconcile values here, and then you can see that finally the stocks table has got Reliance RIL is gone, and Cisco and GM have got added. Okay, so one go, you get it as a batch operation. Any questions? Any questions?
The structure of the table is the same all the time.
In what sense?
Two modes of both the tables.
No, don't need the structure need not be this. You can pass the parameters right out there. Okay, so it's up to you. If the structure is different also, if you map the correct columns, what data is going, it will go. There's nothing that we force you or enforce you. Okay, so that's something that happens. For a parent child.
Yeah. Then how did you set to
didn't get your question.
When the table is character based,
Okay.
then applying mass statement on a table.
Okay.
Then digit statement, how I use digit
Okay.
statement.
Obviously, delete will not work. It has to be delete on cascade. I mean, relationship. It has to be on delete on cascade. See, I'm not talking about. End of the day, it's not about the real procedural code. And I know that there are places where you might have to. You cannot use one. Okay? You will have to get around it. A classic example is this. And I know that all the line of business applications don't use delete on cascade. Because you want to know who's happening or what is happening in your system, who's doing what in your system. Obviously, so those are the places where you cannot use much. Let's be very clear. It's not recommended. It's not.
Is merge only insert updates, delete statements can be used? Or
Yes, only this. Only this. Don't think that this is a mini stored procedure happening here. Okay, nowhere close to it. Don't expect to write a begin and then put a logic in between. It will not be allowed. Okay. First, it's not ANSI compliant. ANSI 2006 compliance gives you the structure. Okay. Very much adhering to that. Apart from that, what I'll try to do next is I'll show you some good stuff. Got close to about 5 minutes. Is there any other questions? I'll show you some fun stuff also on T-SQL, which you wouldn't see people talking about.
Suppose for example, I have a customer table called customer. Okay. I want to pass the data for whatever the data is in the customer table. I want to pass it. So in that scenario, do we need to create another temporary table, another table structure? Okay. Then I have to pass it, or I can use the existing table name as a variable and take the variable up here.
So that's exactly what I was trying to tell you. For any time you want to pass a table line structure, you would have created temp table, table variable, or double hash table. And these three, I told you what the limitations at various levels are. And to remove the limitation that a definition is available within the given structure is when you will go for the type. So type is required whenever you want to pass a table definition. It's only a structure. It does not carry any data. Right? It's a structure. The structure you will have to create it. Yeah. Okay. So I'll show you some things which were not discussed, and because I have a little bit of more time, and if there is no questions coming up. How many know which are the different ways you can script inside SQL Server? Scripting languages. How do you do deployment scripts and all? How do you write deployment scripts? How many have used OSQL? OSQL? Yes? No? I'm not getting a reply. Yes or no? Yes. You have used OSQL. Okay, right. OSQL was good. SQL 2005 introduced a new guy called SQL CMD. I don't know how many of you ever explored. He's a wonderful character. Okay, SQL CMD by the way in which SQL CMD really works. You can do really funky stuff with SQL CMD. In SQL 2008, we introduced one other character which is for .NET type of scripting. It is called PowerShell. Heard about PowerShell? Okay, so PowerShell gets integrated inside SQL Server as a full-fledged scripting language. Okay, so all I need to do to start a PowerShell. There you go. Okay, I'm on the server level. Okay, this is what all I have. Okay, I have databases. Let me go to databases. What are the databases available? Okay, I have AdventureWorks, I have so on and so forth. Let me get into AdventureWorks. Okay, I have tables, so let me get into tables. Okay, so completely scriptable code for databases as a .NET type. Okay, and if you ever wanted to know, okay, what all can I do? Okay, as for the current incarnation, so current incarnation, these are very limited. Okay, so the limited in the sense, let's see, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. Okay. That's all I can do with only tables. Okay. So go down to a different level. You can do anything that you ever like that you did via the UI using a PowerShell script. Completely scriptable. And guess what? You can write your own provider. So you can go ahead and also create your own .NET type, or not a .NET type, or .NET commandlet, we call it as, and use it inside the PowerShell script. Okay, so completely flexible on top. How many have used partitioning? What about partitioning in SQL Server 2005? Yes? Yes? Okay. How many have used it? Did anybody use it? It's quite difficult to use it because it's hard to visualize it, and the only way I could have done this was using T-SQL statements. Right? Welcome to 2008. We give you complete support for partitioning as wizards. Okay, so you can go back and then say that, okay, right, let's do it for contact. Let's create a partition. Partition comes with the wizard. Wizard is right here with me. Okay, so tell me what I want as a partition. Maybe I don't know. I'm just showing you what are different things that I can have. Use that as a data type. That was the wrong table I used. Using others. So let's use city as the new partition function, new partition scheme. I'll not get into the specifics of what those mean, but so if I say till A should be here, till B should be here, till A should be here, till X should be here, and so on. Then give where the data has to go. In this current scenario, I don't have any other partition. I don't have any file system separately. So all I have to do is I say, okay, I'm going to put it in the same file group. Best part of this. It's going to tell you how much of data is available. So go ahead and create that many data files. And the best is not this. Okay? Best is this. This guy can spit out a T-SQL script. So he automatically goes ahead and tells you that, hey, go ahead and delete these indexes, create these partitions, recreate these indexes, everything, keeping all your so there you go. Gives you the whole script and required. This runs on SQL Server 2005 also, without any errors. Okay, so if you have the data type, create the script, come here and do this. Okay, whole bunch on this guy. I'll show you one other thing, which is if you are like a person who does, how many of you have done both tuning or some sort of tuning that you need? The best friend to you till date was what? Profiler. Right? Profiler was good. Pokemon was there. DMVs. But I'll tell you the next tool that you should be using is Management Studio. Okay? Why Management Studio? I'll just show you in a minute now. Okay? This is the last demo. I've already been given time on signals. So what I'll do is I'll talk about. I didn't talk about data collector. Okay, data collector gives you a whole bunch of I'm just starting the data collector view. I'm just showing for server activity. There are for disk and others are also available. We will be expanding this. This is based on DMPs. So what you go ahead and do is that you take a snapshot of your DMVs from time to time, okay, and then build an analysis and then a graph on top of that. Okay, so that's what this guy is actually trying to do. So this guy is telling me, okay, what was my activity in the last 1 hour or whatever it is. So this was the different sets of activities that I was trying to do. I can go back in time and say that, okay, what was I doing during that genre of time, maybe a couple of days back. These were the network and usage. You can go back and then say that, okay, what was happening within that. Go back and see, okay, how each of them have been using. Okay, so there's a lot of information on this guy. Okay, it needs a bit of time. to go and analyze it. How much of time you are waiting for CPU, how much of time you are waiting for compilation, how much of time you are waiting for memory. All these are resources. Obviously, you have to request for the resource. Whenever it is free, it will grant you. And in that process, you are waiting for it. Right? So we have just taken a quick example on it. Wait time. Okay, so percentage wait time. Okay, so in that sense, for me, CPU is the highest wait time, and then compilation, and then memory and so on. Okay, so with that, this is not a T-SQL or an answer, but it's a tool and answer. Yep.
While doing this partition, can I define the volume of data from a particular table to which partition it should go?
Okay. So the question is, how can I define what goes into what partition? Okay. So that's what I did in that drop down list. I said A, B, C, which means that infinity to till A gets into this partition. B onwards till the next partition gets into this volume and automatic. So if you are interested in data, this is the volume of data that has to go, it should automatically partition from that.
Partitioning and the indexing part.
Yes?
And the computation part also.
Yeah?
These are implemented. It will be first while doing the queries on each table set.
It will be, okay, so when various advantages, if you are looking for it, on huge tables, transaction related tables, this makes a lot of sense. It will give you 10 or 100 times of an improvement because you're logically partitioning your lock escalations. Let's take for example, your lock escalation is from what? A row level goes to a page level, moves to a table level in general. If it's a single bulk large table. If it is partitioning, it moves to the partition. Okay, so it means that you are locking the partition, but whereas the other guys can reach some other partition. In the earlier paradigm, you would have locked the table and nobody could read the table. So that's the advantage that you're getting on this. Quickly wrapping up, it was just an hour that we had to talk on this, but there was a whole load of laundry list of features that we could have discussed in this particular session on SQL 2008. Obviously, time wasn't there, but the release of it is very much there in Q3. So feel free, give me your feedbacks, and I'll be very much available for Q&A outside. Okay? I hope you guys enjoyed the session. Thanks a lot.